So we had been discussing that we started discussing with the Prolog, basic Prolog programs, and we had discussed that a Prolog program will contain facts as well as rules. Facts are primitive. You cannot write any Prolog program without facts, but you can write a Prolog program without rules. It means that, like we have discussed in last lab, you can write Prolog programs which will contain only facts. There are no rules because facts specify something which is truth in the real world. But rules are the way how we are going to manipulate whatever facts we have written and infer something. So rules are the way which is giving you power to utilize the facts which you have written. So rules are equally important, but they are not compulsory to be used in a Prolog program. Facts are compulsory. So by now we consider that you are very comfortable in writing facts, at least by the 5 programs we have performed in the last lab. So today we are going to move ahead discussing how a Prolog rule can be written. A bit of introduction of a Prolog rule we have already discussed in the last lab, but we are going to once again discuss what is a Prolog rule. So basically a rule is a predicate expression which is using two parts in itself, as we can see over here in the syntax. A rule is something which is written on the base information, that is fact. A rule is always going to be true only and only if the underlying facts which it is using is true, not otherwise. If the facts which that rule is using are false, then rule is also going to be false. We'll understand this as we will be writing the rules, we'll be practicing them. But first of all, we need to understand the syntax of a rule. How we can write a rule? So over here you can see that a rule is written like left hand side of the rule, then colon hyphen, and then right hand side of the rule and full stop. As we know that every valid statement of Prolog must end with a full stop. So full stop is written at the end. Now what we mean by left hand side and what we mean by right hand side. So left hand side is also called head of the rule and the right hand side is also called body of the rule. Okay. Now how head of the rule should be written and how body of the rule should be written, we need to discuss that. Before discussing that, we need to make very sure that between the left hand side and right hand side, we are using colon hyphen. So a colon hyphen should be used together. And on the left hand side, what we are writing, which is the head of the rule, there are certain rules that we need to remember for writing that head portion of the rule. So let us discuss that. So here, if I write left hand side colon hyphen right hand side, it means left hand side is going to be true if and only if right hand side is true. If right hand side is false, then left hand side is also going to be false. Okay. Now, what all we can write on left hand side? So on left hand side, you can only write single positive literal. It means that you can write only atomic expression. You cannot write multiple predicates separated by operator or expression with multiple operators. Those things cannot be written on the left hand side. Imagine this Prolog rules like the user defined functions which we have used earlier in other languages, third generation languages like C, C++, Java, etc. So how we had written those functions? For writing any function, we had to first of all decide what is name of the function. Then we'll have round brackets. We'll be passing different arguments to the functions. Similarly, when you have to write a Prolog rule, you have to first of all decide what is the name that you are going to use for this particular Prolog rule. Then you need to have round brackets to indicate it is a rule. It is a predicate. So inside the round bracket, what you are going to do? You are going to separate it by comma. You will write either atoms or variables. To be more specific, in most of the rules which you are going to use, instead of using all atoms, you will be using variables as well as atoms or variables most probably. Because that is how you manipulate facts. If you use variables, then only efficiently you will be able to manipulate your facts using the rule. Okay, now you may not understand what should be written on left hand side just by reading single positive literal. So let us see few of the examples of rules where left hand side is valid and for few examples where left hand side is not valid. So suppose we have written a rule like this. What this is valid kind of rule where I have written something like friends. So that is name of the predicate, name of the rule. See, rule's name is also called predicate. Okay. When I say predicate, it is name of the fact also and it is name of the rule also. Okay, and it is always having round brackets with it in facts also and in rule also. Fine. So friends is the name I have decided for my rule. So I have written something like friends in bracket capital X comma capital Y. So that is head of the rule, or we can say left hand side of the rule. Then I have colon hyphen and then I have right hand side. You can observe over here on right hand side I am having two predicates, two facts used separated by comma. So when you use comma between two predicates, what you indicate is or. What you are trying to say over here, if I use likes predicate, this means X and Y I can say are friends if and only if likes X comma Y comma likes Y comma X. It means in simple English like words we can say X and Y are friends only and only if X likes Y and. See, between both of the predicates you have written comma which indicates and. So we will read it like X likes Y and Y also likes X. So what happens over here? Whenever the first likes and the second likes both will return you true, then only the right hand side entirely will be true. Are you getting what I'm trying to say? Because in between you have and. So we already know that true and true only will return you true. Otherwise, true and false is false, false and true is false, and false and false is also false. Right? So only when likes xy is true and likes yx is true, then only the rule friends x comma y is going to return you true. Are you getting a little what I'm trying to say over here? We'll practice this so it will be more clear. Now hates x comma y. Okay, means x hates y. So we are talking only here about x not liking y or x is having certain issues with y. So we can write this rule as hates x comma y colon hyphen. Okay. Now we don't know all the parameters, but we can simply say a person hates another person when the person don't like that person. There can be other parameters also, but just let us make it generic. So we are just writing up about how x is not liking y. So here not is the keyword. It is the Prolog defined keyword that can be used for negating your predicate. So we can use not with the predicate to indicate it is not true. So when x don't like y, then we can say x hates y. So this rule can be written as hates x comma y colon hyphen not in bracket likes x comma y. So what will happen here? Suppose x don't like y. In that case only we will say x hates y. Are you getting what I'm trying to say? Let us move ahead. Enemy is x comma y. So what we are trying to say here, x don't like y and y don't like x. That way we are going to specify enemies. Actually in human language that won't be enemy being enemy, but that will be indifference. But just to make it simple, we have considered rule that x and y will be enemy if x don't like y don't like x. So how we are going to write it? Enemies x comma y colon hyphen not likes x comma y comma not likes y comma x. Okay, so see, can you observe over here that on right hand side we can have multiple predicates separated by and, or you can have single predicate also. You can have different operators applied to that predicate also, like not likes, right? But on left hand side you are writing a single predicate. So that is what I'm trying to convey, that on left side, like the name of the procedure, you will only have the name of the rule, round brackets, and the variables or items you are going to pass separated by comma. But on right hand side, you can write, you must write on right hand side, you are going to write about the predicates which you are going to use, and you are also going to write different predicates if you want to combine them, whether you want to have and, whether you want to have or, whether you want to have not. Those operators can be applied over here. So these can be done with the help of rules. See, you may feel that this sounds very difficult. It is not, as we'll be discussing more examples, it will be more clear. This is just I'm discussing for explaining the syntax. At least it should be clear that in head you are going to write the name of the rule, round brackets and parameters. Then you will have colon hyphen. Then you will be writing certain facts, and you can have combination of facts also. So this is like writing the rule. Now we are going to discuss certain rules where we are having invalid left hand side. So invalid rules. So let us discuss that. Suppose I have written something like left of x comma y, colon hyphen right of y comma f x. So see, this sounds very correct. But why it is wrong? Because full stop is not written. At the end of the rule, you must have a full stop. So this rule is invalid. Let us go to the second statement. Likes x comma y, likes y comma x. So here what happens? That you have multiple predicates separated by and written on left side, which is not allowed. On left hand side, only an atomic predicate should be there. Rule's name only should be there. So this is invalid. The next expression says not likes x comma y, it says hates x comma y. This is also not allowed. On left hand side, you cannot use any keyword or any operator applied on predicate. This is not allowed. Okay, so these are the examples of invalid rules. Let us move ahead and discuss certain simple rules with the same classical parent-child program that we have already discussed. Okay, so over here, just a second, why this is not visible? Let me observe that. Okay, fine. So there are certain parent-child rules we have written. So we have parent relationships, we have male-female relationships also asserted. And now what we are going to do over here is we are trying to write different rules. So these rules will be used for manipulating the facts that we have written over here. Few facts are not visible. Okay. Fine. So, okay, still it is so. So, what we are going to do here, that depending on the facts we have over here, we have to write certain rules. For example, you want to write the rule for child, that what will be the child? If you know only the parent relationship, what will be the child relationship? Means if reading parent Elizabeth Charles, I want to computer to perceive that Charles is child of Elizabeth. Reverse relationship, then you have to write the rule, which is going to use the fact parent. How? So see over here what we are going to do, child x comma y. Okay, that is what relationship we want to create, that x is child of y, colon hyphen means we'll read it like if and only if. So x is child of y, this is going to be true only if y is parent of x, and hence parent y comma x. Are you getting this? Yes or no? Okay, fine. Well, let us move ahead. Mother x comma y. Now see, from parent relationship, how you can get mother? How you can say Elizabeth is mother? If you know that Elizabeth is female, so which all information you will write? Mother x comma y is true if and only if x is parent of y and x is female also. Are you getting this? So how we will write that in form of rule? Mother x comma y colon hyphen parent x comma y comma female x. Okay. Similarly, we can write down father relationship also. Father x comma y colon hyphen when I can say x is father of y, when X is parent of Y and the gender of X is male. Simple, right? So that is what we have written over here in the rule. Similarly, we can write for son also, daughter also, sibling also. Now, before moving ahead, let us try these predicates in the editor. We'll try to write them. So you'll understand that how writing them is very, very simple. Okay. Fine. So these are the predicates which we have used over here. What we are going to do now, based on this, we are going to see, we won't be checking these facts. We already now know that how facts are going to be used. Can someone please let me know whether this is readable? Last time it didn't feel like that was readable.
It is readable.
Okay, fine. Is it readable for with this?
Yes, ma'am, perfect.
Okay, fine. So see, we are trying to write first of all child rule. So how to write a rule? First of all, decide what should be the name. So suppose we want to create child relationship. So I will select the name child. Now, mostly whenever you write any rule, you should be picking up variables, not the constants, not the atoms. Why? Because if you have variable, then only it is going to match with different facts which you have written. If you will write atom in the rule, that rule is going to be static. We will see how. So suppose I have written x comma y here. Okay, colon hyphen. So this becomes the head of the rule. Child in bracket round brackets x comma y colon hyphen. Now when I can say x is child of y, so I will be using which fact over here? Parent fact. So I will write parent. Now if x is child of y, who is going to be parent? Y. So I will write y comma x here. Full stop. See, it's so simple. I can say x is child of y if and only if y is parent of x. So let us check that whether it is this rule is working. So I will write child. Okay. Charles comma Elizabeth. So see, here I am applying the values Charles and Elizabeth, which are atom. But in the rule, I have passed capital X and capital Y variable. So what will happen? Charles, this atomic value will be assigned to X, and Elizabeth, this fixed value will be applied to Y. So what it is going to check in the body? Parent, Elizabeth, comma Charles. Is any such fact available? So it will keep on checking from the first fact. Yes, it is available here. See, when you will run this, okay, so you are getting true, right? You are getting over here true. Forget about all this. We'll check this later. Why you are getting this error? This is because we haven't written contiguous variables. We should be writing them contiguous as we have discussed in last lecture. So let me write them like that. As we already know that all the facts of the same type should be written together. So all the female facts and all the male facts should be written, predicate should be written together, and hence it was giving the error. So if we run it again, see, child Charles comma Elizabeth is true. But if I write here mistake, the spelling is wrong, then it will give you false. Why? Because it will try to find out, it will assign the value of X as Charles and Y as Elizabeth without H. So it will search for the reverse in the parent fact. It will try to find out the value of X as Elizabeth bet, and such name is not available as the value of X in any parent rule, parent fact. So it will return you false. So what it is saying that if this fact is available in your fact base, then only this rule is going to return you true, not otherwise. Are you getting what I'm trying to say? Suppose you have in place of writing variable over here in the rule, if you write constant value, what will happen? If you write constant value, in that case, it will be static. You won't be able to check it with all different variables over here. Are you getting what I'm trying to say? Here you can check like this also. The child capital X, comma, let us say Philip, full stop. So see, you are getting the value X equal to Charles. Means who is X is child of Philip. Then what? Who is X? X is either Charles or X is NA or X is Andrew, like we checked last time. So we can check over here. Child relationship is working perfectly fine. Now let us try to make son relationship. Okay. So once again, son X comma Y. So who will we will call son? So son is nothing but a child, but male child. Are you getting what I'm trying to say? So we can directly use child relationship over here. So I will write child, the same sequence X comma Y, then write comma. What is meaning of comma here? Comma indicates end. So what I want to say, X is son of Y, if and only if X is child of Y, end. So for that end I have written comma. X is child of Y and the gender of X is male. Are you getting what I am trying to say? So see, this is simple how we have written the son rule. So we can write it like son. We can check it like son. Let us say Charles. Charles, comma, Elizabeth. Okay, full stop. So run. True. Are you getting this? Okay. See, this is a question that many students have asked later. So why you are getting true and false also later? So see what it is doing. The Prolog is working on the basis of backtracking. What is concept of backtracking? The concept of backtracking says whenever you ask any query, what it is going to do? It is going to check your fact with all possible facts over here, and it is trying to identify all possible solutions. So for one of the solution, it is giving you true, and somewhere you are getting Charles, you are getting Elizabeth, and you have NA, which is female, and hence for that the child is going to give you false. So it will be like false, sorry, true and false. Elizabeth, NA is child, but NA is not male. So you are getting true, false. Equivalently, it is false, and hence it is giving true, false both. So don't worry if you get such answer. It is because of backtracking. The first answer is the answer which matters. Similarly, we can write DAUGHT here, daughter also X comma Y. Simply it is going to be child X comma Y and then end. Now what we are going to check? Female X. Simple. See, rules are so simple. What you are going to say here? That X is daughter of Y. If and only if X is a child of Y and the gender of X is female. Are you getting this? Okay. Similarly, we can write sibling also, right? Sibling. We can say X and Y are siblings. X and Y are sibling. When we can say this? So for siblings, what should happen? X and Y both should have common parents. So we should write it something like parent Z comma X, means Z is parent of X and the same Z parent Z comma Y. See, if Z is parent of X and the same Z is parent of Y also, then we can say X and Y are sibling. Are you getting what I'm trying to say? Let us check sibling over here, okay, in the facts. Okay, so sibling will check with Charles, comma, NA. Okay, both are sibling or not. Charles, comma, NA. True, see, Charles, comma, NA, both are siblings. Now, see, for other possibilities also, it will give you, true, because it is checking with Charles and Philip also. They are also siblings, so it is giving you true here. Okay, so this is how it is checking for siblings. Are you getting this? Anyone? How to write rule? See, I cannot read your chat messages. If you can unmute and let me know, are you getting this?
Yes, ma'am.
Okay, so we can move ahead. See, using sibling, you can write down simple sister and brother relationship also. Sister, capital X, comma, capital Y. So we can write simply like sibling X, comma, Y, comma. We can say X is sister of Y if X and Y are sibling and X is female. Simple. See, female X. Full stop. Are you getting this? Okay. So here if I'll reverse this, that I will write here NA, comma, Charles. I can check over here the sister relationship. See, right? Now see, NA is sister of the other child Andrew also. So it is giving you 2 times true because 2 solutions will be found. Are you getting this? So see, this is how you write rules. Simply you have to think wherever you have to use and you have to use comma, wherever you have to use or you have to use semicolon. Semicolon indicates or, but mostly when you have to use or, what you are going to do is write separate predicates. We'll see example of or later in other programs. Right now in all the programs you are going to use and only. So let us come back to the presentation that what we had been discussing. So I guess after this discussion, you will be able to write the relationship for child. For mother, mother means parent and female. Father means parent and male. Son and daughter we have already seen. Sibling also we have already seen, right? So this is the first program you are supposed to perform in today's lab. What is the second program? You have to update the first program and add these relationships. How you are going to add this relationship? Uncle, aunt, nephew, niece, grandfather, grandmother, grandchild, and cousin. So who is going to be uncle? Uncle will be not, we won't say sibling, but brother of your father is going to be your sibling. So you have to first of all create brother relationship. Are you getting what I'm trying to say? Just like we have written sister relationship, uncle X comma Y will be brother X comma Z means X is brother of Z and parent Z comma X. Are you getting what I'm trying to say? Similarly, you have to write down aunt relationship. So how this will be made? This will be made with the help of sister relationship. You can say X is sister, X is aunt of Y if X is sister of your parent and then Z and Z is your parent X, Y. In that case, we can say X is aunt of Y. Are you getting what I'm trying to say here? So you can use variable that way. Nephew. Who is going to be nephew? We already know nephew, niece. Then grandfather. See, grandfather will use two parent relationships. I can say X is grandfather of Y if X is parent of Z and Z is parent of Y. Simple. Are you getting this hierarchy? Okay. Now we are not making grandparent, but it is grandfather. So there will be three predicates separated by comma. Parent, comma, male. Because you have to say that X is male. Grandfather, the one you are talking about should be male. Similarly, you can write down grandmother by asserting female in the previous rule. Okay. Grandchild, it will be the reverse of the grandparent relationship. Okay. And cousin relationship. I can say X and Y are cousin if father of X means parent of X and parent of Y, they are siblings. In that case, we can say they are cousins. Are you getting this? Anyone can tell me, are you getting this or I'll have to write these rules? I guess you should try on your own. Yes or no? Will you like to try this or you want me to write? I guess you should be able to write this. They are very simple, right?
Yes.
Okay. See, if you cannot write, I'll anytime explain this once again. But see, this is a simple relationship and you have to experiment. If I'll give you direct code, you won't be able to write down the rule on your own. That's why I'm not giving you code of this. So please try this out. This is very simple. It will hardly take 10 minutes. Now, we are going to move ahead and discuss a new feature of rules, which is called recursive rule. So like we had recursive functions, we have recursive rule also. So what was recursive function that we had used? A function is called a recursive function which we had used in C, C++ or Java, when that function uses itself, calls itself again and again, right? Now, when we had used recursive function, what we had done? Whenever we had used recursive function, we had made sure that we are having terminating condition return. Otherwise, it will go to infinite loop. So these are the very important two things we know about recursive functions. The same applies with recursive rule also. Imagine your rule is nothing but a function, nothing but a procedure, right? So here also, what you can do is the same name of the rule can be called once again from its own body. Just like you had a C function factorial, which was calling itself in its body. Here also you can write a rule where the name head of the rule can be written in body also. So a recursive rule is one which refers to itself. That is, its body indulges a goal which is instance of the relation that appears in the head of the rule. Okay, so we'll see with example, it will be more clear instead of reading the theory. So let me write first recursive rule once again with the same parent relationship. Now see what is called ancestor. If I say ancestor x comma y, what I mean is x is in hierarchy higher than y at some level. X can be parent of y, x can be grandparent of y, or x can be grandparent of y. Are you getting what I'm trying to say? Ancestor can be at any hierarchy. So see, if you need to make grandparent, you don't require recursion because grandparent means parent's parent. But when I say ancestor, I am not aware at which level I am talking about, right? So here what happens? You have to use recursion. So what you need to do over here, how we are going to write ancestor? So see, first of all, you have to write terminating condition. Okay, so we will be writing ancestor x comma y is true if and only if. Can I say your father is your ancestor? Yes. Can I say your parent is your ancestor? Yes, because they are also above you in hierarchy. So they are the first ancestor you have. So that is going to be your terminating condition here. So ancestor x comma y. See, in Prolog recursive rules, the first thing that you have to write in sequence is terminating condition compulsorily. Otherwise, it won't work properly. So we have written ancestor x comma y colon hyphen parent x comma y. Means if it is true, x is parent of y, it is true, then you can directly say that x is ancestor of y. Are you getting what I'm trying to say? If there is a fact, for example, if I'll ask a question like ancestor John comma Paul. Is John ancestor of Paul? So see, it will directly go to the rule. Yes, it is. Why? Because John is a direct parent of Paul. And hence John is also ancestor of Paul by this condition. Are you getting what I'm trying to say? So this is terminating condition of recursion here. But if we are talking about more hierarchies, for example, John is parent of Paul is parent of Tom, and Tom is parent of Mary. So we want to check the relation between John and Mary. Ancestor x comma y colon hyphen. So see, now imagine that we are talking about x is ancestor of y. In that case, we are not aware that how many layers are there between x and y. But we are definitely sure that somewhere x has a child, let us say z. Okay, and that z is going to be anyway ancestor of y. Are you getting what I'm trying to say? There may be multiple levels, but then in that case, anyhow, x is going to be x will have some child y, and that y will have be ancestor of z. Uh, X will be having a child Z, and Z will be ancestor of Y. So we'll write it like ancestor X comma Y colon hyphen parent X comma Z comma. Once again, I'll call the same rule recursively ancestor Z comma Y. Let me explain this. Let me explain this in other ways here. Let me explain this ancestor concept once again. Fine. Okay. I'm just trying to explain you hierarchy. That suppose this is I'm talking about ancestor x comma y. In that case, let us imagine this is the ancestor. We are talking about ancestor x comma y. Okay. So how hierarchy you can visualize? That there is some x who is ancestor, and here at bottom somewhere we have y. Okay, so that is child. We don't know how many parent we have in between. Are you getting this? But somewhere we are aware that there will be some direct relationship between x and z, such that x is parent of z. Are you getting this? We don't know how many parents are there between x and z, but definitely there is going to be some direct child of x. Let us say z is direct child of x. Means you have a relationship which says parent x comma z. Okay. Now again you don't know how many levels you have between this z and y. So can I say z is ancestor of y? Yes or no? So here again recursively I can call ancestor z comma y. So once again what will happen? This is a recursive call. So when you call ancestor z comma y, imagine that here somewhere you have z and here somewhere you have y. Once again there is going to be, let us say, some z1 direct child of z available, such that there is a relationship, parent child relationship between z and z1, parent z comma z1. So direct parent relationship is there, and I can say z1 is ancestor of y. So once again I will call ancestor recursively. So this is a recursive call. So once again what will happen? Somewhere you have over here z1 ancestor and y as a child. You don't know how many levels are in between, but then you are sure that there is going to be some z2 child available, which is a direct child of z1, parent z1 comma z2. Pardon my very bad handwriting, I am not that good with Jamboard, but I thought explaining hierarchy is important. So parent z1 comma z2 is a direct relationship. Then you don't know how many levels are there between z2 and y directly. So what you have to do, once again, call ancestor relationship. Now you will keep on calling this unless and until you can say directly that Z2 is parent of Y, direct parent of Y. So this is nothing but terminating condition which we have discussed. Are you getting a little what I'm trying to say here? See, once again, if you observe here, what we have written in ancestor relationship, what happens here? The terminating condition says x is ancestor of y if and only if x is parent of y, and if it is not the case, if it is directly not, suppose I am taking checking like ancestor John comma Mary. Is John direct parent of Mary? No. So this won't be true. This won't be true. So what will happen? It will go here. X is John and Y is Mary. So how you are going to call now? Parent John, comma. You don't know the value of Z. So let it be Z. Parent Z, John, comma Z, comma. Ancestor Z, comma. What is value of Y? Mary. Are you getting this? Now see, you have called ancestor recursively. So once again, it will check this. That is direct parent relationship available? If not, then the recursive call will be executed. And finally, where you will reach? Finally, you will reach to Tom Mary. The Tom is the direct parent of Mary. And hence this will return true. Are you getting this, students? Padhe che khabar? Can someone please acknowledge?
Yes, ma'am.
Yes, ma'am.
Okay. So see, writing recursive rule here is very simple. Just you have to understand why recursion is used and what is the underlying hierarchy. Now, if you have understood this, then it is very easy to write the descendant relationship also. Like we have an ancestor, they are upper in the hierarchy. We have descendants also, they are lower in the hierarchies. So if I say X is descendant of Y, then Y is some ancestor and X is some child below the hierarchy. So in earlier relationship, we have used parent relationship as the base relationship. Here we'll be using child relationship as the base relationship. So I am using child X comma Y, parent Y comma X rule as the base rule. And for descendant rule, what is going to be terminating condition? I can say X is descendant of Y directly if X is direct child of Y. So child X comma Y, simple, just like we did earlier. The terminating condition is same. Instead of parent, now I have child, simple. Now if this is not true, if you are talking about so many layers in between, then what will happen? Descendant X comma Y is true if and only if. Means X is descendant means X is child of some Z, and Z is descendant of Y at some level. Are you getting this? See, once again this becomes true. This hierarchy becomes true. I can say Y is descendant of X at some level. You can relate with this. Okay, so considering this, again this works like the terminating condition is clear to everyone, and X is descendant of Y if direct relationship X is child of some Z, and that Z is descendant of Y at some level. So unless you will reach to terminating condition, it will keep on recursively call descendant rule relationship. Are you getting this, everyone? Yes or no? If you have understood ancestor, this should be clear. Yes or no, anyone?
Yes, ma'am.
Okay, so this is just reverse, so I'm not taking much time. Now this is the next program you will be doing, the third program. The fourth and the last program that you have to do is recursive rule for graph. The same graph program we did in last lecture about directed and directed graph. Here also we can use rules. We can use recursive rules also. So suppose you have the fact age A comma B, age B comma C, age C comma D, age D comma E. Means an age is going from A to B, B to C, C to D, D to E. Okay, I'm just giving you example for showing connected ages. If I want to check the vertex A is connected with E or not, means there can be any number of edges between A and E. We are not sure. So we have to write a recursive rule. I'm not talking about transitive age. What is a transitive age? If I have age from A to B and then B to C, then it is called transitive age, T age. T age can be simply written like T age A comma X comma Y is true if age X comma Z, age Z comma Y. Means there are two consecutive ages available, then it is transitive age. But if you check connectivity, means between X and Y there can be any number of ages possible. So this can be written as, first of all, what will be terminating condition to say X and Y are connected? When there is a direct age between X and Y. So connected capital X comma capital Y is true if and only if there is a directed age available between X and Y, full stop. This is terminating condition. Now if it is not true, then we have to have a recursive call. How? Connected X comma Z colon hyphen. Now see, you don't know how many ages are there between X to Z, but you do direct age from X to Y first of all. So age X comma Y, a direct age is there between X and Y, and Y is connected to Z at some level. So connected is recursively called passing Y and Z. Just like ancestor and descendant we did earlier, connected can also be written. What we are doing here, X is connected to Z if and only if X is connected directly by an age with Y, and Y and Z are somewhere connected with each other at any level, then we can say X and Z are connected. Are you getting this, students? So the next program that you have to do, the fourth program you have to do is, for this graph given over here in this slide, you have to write down the age facts. See, this is a directed graph, so accordingly you have to write down age facts. Then you have to write down connected recursive rule. Also write down T age. I will revise the practical list. Transitive age. What is a transitive age? If A is connected with B and B is connected with C, then you can say it is a transitive age present. So connected and transitive both rules you have to write. Transitive won't be recursive rule. It will be a simple rule, while connected will be recursive rule. So that you have to do today. Okay. So these are, I will revise the fourth program before you start doing the programs. So these are 4 programs you have to perform today. First program is basic relationship rules, like we had discussed earlier here. This one. This is the first program. This is the second program. Rewrite the first program, and there you have to add these rules. That is going to be your second program. Okay. What is your third program? This ancestor and descendant. These two. These two you have to write as recursive rules. So what you have to do? Write down the aim, then write down the program and write down the output. Okay. Fine. This is the fourth program, but you have to do for this particular graph, the fourth program. Okay. So these are all the programs you have to perform today. If you have any doubt or query, you can ask. I have recorded this session just for the purpose that in case if you feel any doubt or difficulty, you can refer to the recording and understand it once again. So that's all for today. If you have any query or doubt, you can ask. If you don't have any query or doubt, then you can leave the meet and perform the programs. Me and Nirali ma'am will be available for 2 hours online